It should be in the slide. Yeah, it's in the slides. I just like monitor the back end and make sure they get filled out because I want to make sure.
Cool. Good morning, everyone.
Good morning. Good morning.
Wow, less energy on a Monday morning than on a Friday evening, I see. Today, lecture 3, using variables. Before we hop into the actual material, our first part is going to be talking about tech opportunities. So I'm excited to invite Nathan, who's a recruiter at Google, and you can give more of an intro, and then Ernest Holmes, who some of you know from Codehouse and who taught here last year as the GIR. So I will turn it over to them, and you can drive the slides as well if you're ready to move on.
Awesome. Thank you, Ashwin. Good morning, everybody. Good morning. My name is Nathan. I work on our university programs team here at Google. And essentially, my job is to help you all get full-time jobs and internships. That's what I do full-time. I'm here to support students, help connect you to the right opportunities, provide you with programming and resources to ensure that you feel as confident and comfortable pursuing opportunities as a tech student, whether you want to apply to Google or anywhere else. So that's kind of what we're into here. And as we know, we have this GIR program. So one thing we do actually need folks to do is ensure that we fill this form out, because this is basically how we track all the students that are in the GIR class. So it's just going to ask you like your name, your email, things like that. But at the end, you'll have the opportunity to opt in to receive updates around all the types of events that we do. So like resume workshops, internships, scholarships, things like that. But if we get everyone, go ahead and fill that out real quick, and we'll just keep talking here as you do it. But we just want to ensure we have everyone in the GIR class enrolled, because we've been doing GIR. Are you all familiar with the GIR? Ashwin, I'm sure you.
One slide.
Okay, yeah. So basically, since 2013, we've been sending Google engineers to different HBCU and HSI campuses to teach introductory level computer science. So it's a program that we've been running for almost 10 years now, and we're always trying to make it better. So we like to see, well, which students are enrolled and how we can better support them throughout the program, get an idea of what sizes are year over year. So that's why we have everyone fill these things out. But yeah, essentially, I'm your dedicated contact throughout this entire school year. Anything that you need, I'm here for. If you ever have any questions and you need them to get passed to me through Ashwin or anyone else, that's what I'm here for. We try to connect folks to opportunities. We try to make sure that you have all the information that you need to feel successful when applying for different technical roles and opportunities. So our events, of course, will be a bit Google-centric, right? But everything that is taught in our events will give you the skills and the knowledge that you need to navigate the tech industry. So we like to start early. We like to ensure that you have all the information up front so you can start making decisions as you're going through your computer science career about what's going to set you up best. So that's part of what GIR is about. That's part of what all of our programs are about too. Which is why today, actually, this evening at 6 p.m., you may have seen this, and I have a slide for it coming up here soon, but we actually have an event tonight. We're having a panel. We have some Morehouse alum and a Spelman alum that are back on campus today, 6 p.m. in Merrill Hall 111. They're going to be speaking on a panel about how they went through their computer science program, how they ended up at Google, what advice they have for rising computer science students, and what they suggest that you do as someone that wants to become a software engineer or programmer. So we have events like that throughout the semester. We'll be on campus a little bit. We'll have things going on virtually, but we'll share more information about that just in a moment here as everyone gets this form filled out. Corners, do you want to introduce yourself?
Yeah, sure. What's going on, everybody?
I said, what's going on, everybody?
I know it's Monday, but come on, give me some energy. What's up? Some of y'all know me in this room, but if you don't know me, my name is Ernest Holmes. I'm a 2019 graduate of Morehouse College, computer science, mathematics double major, so I was quite literally in these seats just a few years ago. I went through all the Google programming. I actually got my first internship at Google my freshman year, right? So quite literally, the things you guys are learning now can actually be applied to interviewing and then interning at Google. How many of y'all want to come intern at Google? Everybody? Just not you? All right, cool. I'll take it. But so I 3 years as an intern at Google, then a software engineer for about 2 years, and then I was just in Ashwin's position last year, teaching this class at Morehouse. Right now, I work on a team called Education Equity that helps run GIR and a really cool program called Tech Exchange, where we're gonna have another informational on Thursday for that. At the end of the day, y'all, come to all these events because we want to get to know who you are. When Nathan said he is your person, everyone in this room should know who Nathan is, and he should know each one of you guys, because he will be your plug to make sure that you know about the application, the interview process, and making sure that you guys are on your stuff, resume-wise, application-wise, all that. Are y'all with me? Are y'all with me?
Yes, sir.
All right. So show out. You know, I want so many more Morehouse brothers to be at Google, and if y'all ever need anything from me, I'll be around as well. All right.
And once you all fill this out, I'll be able. Oh yeah.
Oh, you said what room in Morehouse?
Oh, we're gonna throw up here in a second, but it's 111. Yeah, we're gonna throw up here in a second. Just want to make sure we get everyone to fill this out. Once you do, I'm gonna send everyone an email, so that way you have my email in your inbox. Please utilize it. I'm never bothered. You can message me anytime about anything. Just want to make sure that you all have my contact information, so you can always send anything that you're curious about my way, and we can get you the right information that you need to be successful. So. We're just waiting. I think we have mostly everyone has filled this out. We're still waiting on maybe 4 more. So we can just get, if you haven't filled this out yet, please it's real quick. Name, email, address, things like that. I just want to make sure this is going to get you set up for all of the different opportunities and the applications and stuff that are coming out. So we want to make sure that we have your email captured here. But yeah, and again, tonight, we're going to share the information here in a second, but we do have some alumni that are here talking about their journey to Google, talking about their experience here at Morehouse or the AUC. So we're excited to get you all connected to them and throughout the semester meet a lot of different Googlers and learn a little bit more about what it is that you can do to be successful as a computer science student. Any questions about what we do here at Google or what these programs are like?
Don't be shy, yo. I know it's Monday.
I don't want to take it.
All right.
That's okay.
Wait.
Yeah.
Nathan, we haven't even learned about variables yet. How can we be doing interviews and all that right now?
That's right. So the software, the internship that we're trying to promote here is our STEP internship, which is intended specifically for first and second year students, right? Which means that we're only expecting first and second year experience. In fact, there are 2 applications for the STEP program, a first year one and a second year one, right? So if it's your first year, that's the one you apply for. Applications will open around mid-September, which sounds early, but you don't interview until second semester, right? So you have a whole semester of computer science under your belt before you have to even think about technical interviewing. And that's what we also try to do throughout the semester is provide you with the programming and opportunities so you know exactly what's going to show up on those interviews so you can practice them throughout the semester. So by the time December, January comes around, they actually start, you feel prepared, you've done a few mock interviews, you know what to expect. So if you think, in virtue of you being enrolled in this class and being a computer science student, you actually meet the minimum qualifications to apply. These are the types of students we're looking to engage, right? Freshman computer science students currently taking a class. So you meet the minimum requirements to apply. From that point, it's just making sure everything on the minimum requirements are listed on your resume, which we'll talk about throughout our programs throughout the semester, and also making sure you start practicing for interviews and things like that. So it's intended for first years. It sounds kind of daunting to be like first week of class, let's apply to a Google internship, right? But again, the application will open mid-September and we'll have a lot of resources to help you get that in. And you don't even have to think about interviewing until next semester.
Do y'all know what an internship is? Can someone stand up and tell me what an internship is? Anybody? Oh, Freddie, thanks. Let me hear that Morehouse introduction too.
Sure. All right. My name is Freddie Golden. I am a freshman computer science major from Chicago, Illinois. And basically, an internship is where you get like the intro to like a company, or like you come in and they take you through like it depends, like a couple week or a couple month program. They kind of teach you the basics a little bit, maybe train you a little bit, but it's like different for kind of some programs. But basically, when you come in, you get introduced to a company, and you can lead into a job out of an internship.
Cool.
Basically.
And you get paid for an internship?
Yeah, you do.
Okay. Y'all know about, on average, how much interns get paid during the summer? Anyone want to take a guess? $20,000. Okay. Cool.
Anyone else? Do an internship again.
Well, I mean, hear me out, right?
Listen, yeah, it's not.
He's not that far off.
If you adjust for month by month, yeah.
If you adjust month by month, right? You probably leave an internship with around $12,000. Plus, they'll pay for all your housing and your relocation. At Google, like we just came from the Google office right now. The food is fire and it's all free, breakfast, lunch, and dinner, right? So you're getting a lot of your expenses not even, like you don't have to pay for any of that, right? And on top of that, you're making all this money. But the coolest part about internship, it's a 12-week program for Google.
Yep. And
you're actually working on real life Google problems. You're not sitting there photocopying and like being an admin or anything like that. You're actually working on projects that are business critical for Google. Right, so I did 3 internships while I was at Morehouse, all at Google, and some of my code to this day from my internship is living, breathing code that's worked on different products at Google, right? So you're actually having impact on the company that, like, whether thousands, hundreds of thousands, millions, or billions of people are actually using. So it is a bigger deal, right? And that's why
Yeah.
like, I'm here to tell y'all, like, if I can do it after a freshman, right, y'all can too.
Yeah.
But we want to make sure you guys are aware of the process and have all the skills, tricks, and tips that you need to make sure that y'all can get it too.
Yeah. I mean, Google is super data driven. Like, we're here for a reason, right? We've seen historically Morehouse students in this intro class do well in our process, right? It's a great return on investment for Google to come to Morehouse and be like, hey, we need you to apply as freshmen because we hire a lot of you and end up contributing really significantly to the company, right? So people who are in your position this time last year were interns at Google last summer, right? So it's possible. It's something that we see as a great stepping stone for folks to start their technical career. So we're here because we know that folks in this department do well in this program, and we want to see you apply and see you be successful. So like, this isn't just something we don't do this everywhere, right? Like, we're here because we know that this school and this department has a track history of success, right? And we want to help continue to promote that success. So we're here for a reason. Like, we're here because we believe in you. We're here because we want to see you succeed, and we know that you can. So it's a first-year internship, right? Like, all we need is first-year experience. Even if you're kind of iffy, like, we still encourage you to come out to these events and learn a little bit more about it. And the application itself, we'll get into more of this as the semester goes on, but it's super easy. It's just a resume and unofficial transcript, super easy application, so super low risk to apply.
For sure.
Cool. I don't want to cut in too much into your class time. It seems like we got most people to fill this out. If you haven't, please just take a photo real quick or take this in, but I think we have most folks that have filled this out. But I want to get to tonight. So tonight at Merrill Hall, we have an AUC alumni panel. 6 p.m. Eastern Standard Time. We'll have some food. We'll have some Google swag there. We'll have 3 alumni, 2 from Morehouse, 1 from Spelman. They're going to talk a little bit about their experience as a student. They're going to talk a little about why they chose CS, how they decided to pursue their internship or professional experiences, and what makes them successful now as a programmer, and their number 1 advice to AUC computer science students. So it'll be a good time. You have a chance to network with Googlers, learn from folks that were in your position not too long ago, and just learn a little bit more about our programs. Do you want to talk about the tech exchange one?
Yeah, for sure. I was also the office hours, right? Because we're gonna be around.
Oh yeah, so we do have office. So this resume, this RSVP link will also, you'll have an opportunity to sign up for office hours too. They are getting full, so you want to apply relatively soon. But we'll connect you. There's office hours that we have going on Tuesday, so tomorrow.
We'll be right in that room. If you see that we're just hanging out, feel free to come through.
Yeah.
Your resume is super important, not only just for Google, and I'll just say that because I want you guys to get internships regardless of where you end up, right?
Right.
It's very important that you put certain things on your resume so that you don't get flagged out of the process, right? Like Nathan said, since you guys are in this class at Morehouse, computer science and software engineering majors, you guys are qualified not only for Google's internship, but a lot of other companies' internships. But it's the way the verbiage that you use on your resume is super, super critical. Okay? And Nathan is like a subject matter expert on that, so you want someone like him to look over your resume.
Right.
Are y'all with me?
Yes.
Okay.
Yeah. So even if you see, even if the office hour slots are full on the sheet, still come by if you have time, because I'll be there. So the slots are just to meet with the alumni, but I'll be there the whole time. So if you want to stop by, get your resume looked at, chat through, or like try to squeeze in a meeting in between their scheduled times, you should be good to go. So that's tomorrow. And I'll also send an email out to everyone that signed up on the form with that form as well, so you have it.
And I should be there too. Not gonna lie, y'all, I need a haircut, you know. So like, I might be out for a little bit, but I'll be there most of the time too to look over resumes and stuff.
Yeah.
On Thursday, we're gonna have a tech exchange info session. Y'all probably like, what is tech exchange, right? So we actually have a program at Google that you guys can take classes from Googlers, right, and get credit at Morehouse for it. So you're actually learning from real life Googlers, whether they're AI engineers, product managers, or whatever, and get credit at Morehouse. It's a special partnership between Morehouse and like 15 other schools. So you guys are like special because y'all are able to do it. You're only allowed to apply your sophomore year, but I think it'll be very important for you guys as freshmen to come to it so that you guys can think ahead if you want to be in this program. We have a whole tech exchange facility on Google's campus, like the office or building names are like Spelman College and Howard University and all that good stuff, right? But this is a great program for you guys to apply to when you're sophomores. Right, we'll also have food, we'll also have some swag to give away. My manager's coming, so I'd love for y'all to meet my manager. She's great people, but that's gonna be on Thursday. Most likely gonna be a Mero 111, we're just making sure that we have the room actually reserved. Cool? Y'all with me?
Yes.
All right. Cool, thanks so much for giving us the time, Ashwin. Thank you so much for giving us the time, students.
Any questions, y'all, before we head out? Come on.
What time is the office hours again?
They're going to be from 10 a.m. to 3 p.m. So I'll send an email out with that information.
Ooh, she graduated. She's fine. But the cohort 1 students should be there. They were actually required to come, so y'all can come. Yeah. Yeah.
Oh, yeah.
So for the internships,
Yeah.
are they just like coding based, or is it?
What's your name, man? Can I get a Morehouse introduction?
My name is Sandra. I'm a sophomore here, computer science major from Naples, Florida.
Nice to meet you.
So yeah, I was just wondering, are the internships at Google just coding for computer science, or is there any other type of like?
Yeah. Good question. Good question. So for first and second year students, we just have technical software engineering internships. At the junior level, we have what's called our Bold internship, which is a non-tech, more business-oriented internship where you can match the different parts of the business. But for first and second years, it's just software. Yeah.
What you want to go for is a step internship because that's a great pipeline into Google, right?
Yeah.
And if you're interested in doing things outside of strictly software engineering, like one of my internships, I was literally working on like a robotic flower. So I got that hardware component, I got a little bit of machine learning component to all that as well, but it was a software engineering internship. But on top of that, you develop a lot of business skills because you learn how to communicate, share with different partners or stakeholders in the company and all that kind of stuff as well. You with me? Because you're what major?
I'm a computer science major.
Cool. So you want to go for the step internship.
Okay.
Cool.
For sure.
Any other questions, y'all? This is your time right now. We with you. No questions at all?
We're around all week too, though. So
Yeah, we're here.
yeah, we'll be. I'll be here in that room all day tomorrow.
Cool.
Awesome. Thank you for the time. Appreciate it. Basically,
Yeah,
if you
thank
see
you.
anyone with a Google shirt, feel free to stop them and talk to them. There's going to be a lot of us here this week, so feel free to connect with us. We're happy to chat with whatever you need.
Cool. All
All right,
right.
y'all.
Thank
Good
you.
luck.
Thank you, Ashley.
Yep.
Thank you.
All right. So we're gonna hop into memory. I know we kind of talked at you a lot, so I'll give you all the chance to talk in your little groups. So in groups of 2 to 4, I want you to think about a memory from your childhood that stands out, either a family event, some big moment in your sports or activity, just something that you remember from your childhood, just to get you all talking. So let's split up into groups. You can move your chairs around a little bit.
What have I suppressed? It's my grandpa's. He used to have it was like all at the house. It was super nice.
I'm in one
All right, 30 more seconds. All right, let's wrap up conversations, bring it back. Okay, so the human brain is kind of incredible in that, when you have certain contextual clues, you remember stuff from your past. And somehow your brain is able to pull back memories from dozens of years ago. Likewise, computers also will need to store lots of data, lots of memory, so that when we need it in a given program, the computer can go and pull from the specific spot so that we can actually use that data in our program. So I'm going to share kind of an overview of how the computer will store different data. So in a computer, we have these individual boxes called bytes. You might be more familiar with the term gigabyte, because when you buy a phone, they'll say, it's 32 gigabytes or 64 gigabytes. A gigabyte is 1 billion bytes. So if it's 32 gigabytes, that means it literally has 32 billion of these individual boxes, and each one of these boxes can store a piece of data. A byte of data will typically store one character. And so if we wanted to store the name jaw, it would store the J in one box position. We'll just call this position 0, even though it's like 114 billion. I just put a big number there to show how big the memory space can be. But we'll call this like storage 0, storage 1, storage 2. Before we continue, does anyone know what data type this name is? Jaw. String, double quotes, and it's like a string of characters, yeah. So when the computer stores a string in memory, it will store each character in its own box, because each character takes up a byte. So the J will be stored in the 0th position, the A will be stored in this first position, and then the computer will automatically add what we call the null terminator. The null terminator is just the value 0, and it's to help the computer know where the end of the string is. Because we will have like more data on the side of the screen, so the computer needs to know like which part, the start and the end. It has to know where it's starting and where it's ending. And so this null terminator character is just to help the computer know where the string is ending. Let me close this door. Are there any questions on that so far? Yeah, question.
Is the null terminator always represented by 0?
Yep. So each of these characters are also represented by numbers. At the end of the lecture, if we have more time, I'll show how the mapping is done. But the J will map to like number 16, and this null terminator will map to the number 0. Any other questions? Okay. Let me just check my notes to make sure I didn't forget anything important here. All right. Each memory address can hold 1 byte of data, equivalent to 1 character. Okay, and then what we call for memory, it's called RAM, random access memory. Cool. Okay, so there's all these memory addresses. How can we as programmers actually remember where all the memory is stored? Like if we create the name jaw, do we have to go and remember, oh, like it's stored in position 114 billion if we want to actually use that data? That would be very hard for us as programmers to remember. We would almost need like a little side sheet where we write down each memory address, and that'd be very tedious and very difficult to use. And so in computer science, we have this term which is called a variable. And a variable will be used to help take care of that mapping between where we define a type and where it's actually stored in memory. Yep. So how can we access these stored values? You know, there's billions of memory addresses. How can we actually keep track of it? And that's what the rest of this lecture is going to be about. It's going to be learning about variables and how we can use names instead of having to remember all these different exact memory addresses. Cool. Okay, so I have a little bit of code. Normally there will be a few lines above, right? It'll say include IO stream above, and it'll also say using namespace std. Just to like keep it short, I'm just using the main function. And in the main function, we can define a variable using the data type and then the variable name. So as we talked about earlier in class, jaw is a player and the name is a string of characters. So we first say what the data type is, and it's a string. That's why I've been really quizzing you all on Friday about setting data types, because when we create variables, we have to know what the proper data type is. Then you put a space, and then you can create the variable. So this variable can be any name that you want it to be. You define this name, but we want it to be something that makes sense. If you were just like string s, that would work, but we wouldn't know what s means. And so if someone were to come and read your code, they would be confused as to what your code is trying to do. So when you choose variable names, we want it to be descriptive to the problem that we are trying to solve. Any questions on that? You'll be doing this probably 1,000 times in this class, defining variables. And again, it's just you type the data type, and then you type in the variable name, and you get to create the variable name.
So
yeah.
It's just basically you create that name.
Mm-hmm.
It's not always going to be the same name.
Correct. It'll be different each time. And in Wednesday's lecture, there's some names that you can't use for variables, and we'll discuss that on Wednesday. But for the most part, are we good on attendance?
Everybody wrote it down?
Everyone good on? Okay. Thank you. Okay. Okay, sweet. Let's move on. So under the hood, what's actually happening? When you have that line that says string player, the compiler sees that and sees that you're trying to create a new variable. And so under the hood, the compiler has its own little mapping. And it will say, okay, I've seen the programmer has created the new variable player. Let's map that to some space in memory. And so this is just an example. I just said it maps to 114 billion, but the compiler will map it to any open space that you have in memory. And then let's say you also created a variable called int age. That would then be, if we had more boxes, you can imagine like this is going billions of boxes long. You could have another one at position 3, and it'll say, okay, the age variable is going to be stored in that new memory location. Each data type has a different size. And so that's why it's also important that we have to define the data type. For example, an int will have 4 bytes. So it'll need 4 of these boxes in order to store the value. However, a double will typically take up 8 bytes of memory. And so we have to define it at the beginning so that the compiler knows and is able to allocate space for each of these variables that we'll be using. A string, the size will depend on how long the actual string is. And so in the case of jaw, it's 2 letters, plus you have to add 1 for the null terminator, so that would be a length of 3. You don't have to memorize the exact numbers. This slide is more just to show you what's happening under the hood when you actually create a variable. Yeah.
So player and age are 2 different variables, like they're just examples of the 2 different variable names, and then those numbers are the addresses that were open that they were assigned to.
Yes, exactly. So just to repeat it so that everyone hears, player and age in this example are 2 different variables, and so they'll each get their own memory location, and the compiler will take care of finding open space to assign that. So instead of us as programmers having to write down each of the numbers, all we have to do is just remember the name. And so now I'll go to the next slide and I'll illustrate it a little bit more. Now, whenever player is referenced, the computer or the compiler knows, okay, go to that memory location, and we'll be able to get whatever information is stored there. A lot of information. Any questions so far? Yeah.
Can you manually assign where your data is, like what number your data is assigned to in your RAM? So instead of 114 million or whatever that is, could you have assign it to 150 million or something like that?
I don't think you can. I think I'm sure if you really dug under and modified the compiler, that's why I'm a little bit hesitant to answer. If you went and modified the compiler, then maybe you could, but traditionally we have no control. And now computers have gotten so complex with dynamic memory allotment, where it might even assign it to one place in the beginning, and during the course of your program, it might even be reassigned to a different location later. So short answer is no, you don't get to decide, but there's no reason for you to need to decide, because the computer will take care of it for you. Yep. Any other questions? So now we've talked about variable definition. So that's where you set the data type and then you set the name that you want. Now we actually want to store information in that spot. And that's what we call as variable assignment. As the word kind of implies, we assign a value to the variable. So in this second line of code, we say player is equal to the string job. So in this case, let's just step through what the compiler is doing. In the first line, it takes string player and sees, okay, we have a new variable player. it's a string, so we need to go into our memory bank and save some space. And that's what it's doing here, where it says player is going to be stored at that position. The second line is then saying player, so as soon as the code sees player, it says, okay, let's jump to that 114 billion position, and it says, let's add the word jaw to that position. And so if we were to go forward one slide, it will then, starting at this position, it will add the first letter J. Again, only one character can fit in each box, so after this box is full, then it goes to the next one, adds the A, sees that we're at the end of the string, so then it adds the null terminator. And so just like that, the memory now takes up 3 bytes, and anytime, or we'll get to it in the next slide. Are there any questions on this so far? Yeah.
So, int main, that is just like for C++ specifically, and that's just what you put before, like does that go before every, before you put anything in, or is that just for strings, is that just for, like where does that go specifically?
Yeah, good question. So every C++ program will have, and we'll cover this in lab as well, but I'll show it here. Okay, so every C++ program will have these 4 lines. So include IOStream, that's just to include code so that we can do input and output, and allows us to print to console. Using namespace std, you don't need to worry about that too much. It's just saying use the standard library. And then this int main with the parentheses and then the curly braces. This is the part that will always run in a C++ program. So anything inside these curly braces is essentially our program. And we call this the main function. And so anything we put in here, if we want to print something to the console, like hello world, this will allow it to run. And so also now if we want to do something like int age, it has to go inside the main function. If we were to put it outside, I think it'll error, but let's see. It might just keep it. Okay. So you can define, but in order to do stuff with the variable, it would have to be inside the main function. Yeah, question?
Sorry if this question seems a bit redundant, but at the end where you say JA equals assignment statement, what exactly is the assignment statement?
Yeah, good question. So the assignment statement is this entire line. So it's saying take the variable player equals the string jaw. So now at any point later in our code, whenever we have the word player, you can think of that as being equal to jaw.
Oh, okay.
So it's setting the 2 equal to each other.
Okay, I got you. So X might be the name of the variable, but X would represent like 5 or 6 or something. And so 6 would be the assignment statement.
Yes, like that x equals 6 would be the assignment statement, yes. Yep. Any other questions? Okay, so now this kind of leads into your question of how we can actually use it. So, cout will print stuff out to the console. And so if we were to have this statement, player is a grizzly, does someone want to take a guess at what this will print out to the console? Yeah. Jaw is a grizzly. And why is it jaw is a grizzly and not player is a grizzly? Yep, exactly. Just for people who didn't quite follow that, when the code comes to this line, it will see this word player, and it'll be like, where have I seen player before? And it will remember, based on this compiler mapping, it'll be like, I know I've seen player before. Where is it? And it's like, okay, it's stored in this position. So it will come to this position here, right? And it will say, okay, let's get the word that's stored in this position. So it'll take the J. There's no null terminator, so it'll keep going. It'll get the A, no null terminator, so it'll keep going. And then it comes here, and it's like, okay, I've gotten all the data I need. And so player is equal to jaw, and the output will be jaw is a grizzly. All right, a lot of information again. Any questions?
So, if you don't put one, it's not gonna work right.
After the main.
Right. It says, is it busy?
Mm-hmm. Oh, like the double quotes?
Yeah.
Yeah. Yeah. So the good distinction. So player in this case is a variable, and then is a grizzly is the string literal. So it's kind of like how we did the hello world. We're now combining two of them together. So yeah, if you didn't have the quotes, it would think like, it would look for the word is. It would think is a variable, and it would go and see like where's is, and it would say like there's no variable named is. I don't know what you're talking about. So that's why we need the double quotes around that. Okay. Any other questions?
Oh,
Yeah.
in C++, do you need the semicolon after every order?
It will be at the end of every statement line, which is, yeah, like each of these 3 lines has a semicolon at the end. The exceptions will be if you notice like after the main curly brace, that's not yet like a finished statement because the other curly brace is still at the bottom, so those don't need semicolons. And again, that's something as the more C++ programs you do, the compiler will tell you if you put one in the wrong place or if you haven't added one, so you'll kind of pick up on it. Any other questions? Okay, let's do some live coding and see some examples. All right, sorry, no, before we get into live coding, I have, I'm gonna pass around Post-it notes to each group, and I kind of want you, based on what we've discussed, to try to come up with your best idea of a definition of what a variable is. Before we go together here.
That's how we some that
I was
some you can change changes basically.
low key what a code.
What you assign to, changes on
All right, get your definitions down on the Post-it note, then I'll come around and collect them. Cool. I think a lot of these are really good. Okay, a placeholder that represents the location of data stored in memory. Cool. So this idea of the variable referencing the memory location, and a placeholder, so it actually holds data. I like that a lot. Something that represents a data value. Yep. Some representative term that holds an assigned value. So I'm really liking these words of like representative or placeholder, right? They're all getting at like, you know, like the name player isn't actually jaw. Like it might change later in the code, and on Wednesday we'll show how the values in a variable can change. But it's this idea of it represents the string jaw, or it represents the value age. Something we give a name that can be substituted for data. Yep, and I like that it's calling out like we give it the name, we have control over it. Something that is interchangeable, we'll learn that on Wednesday, how you can change the values. a piece of code with an assigned value that can be used interchangeably with that value. Yep, so as we saw here, when we say player, that's essentially saying the same thing as jaw in this case. Whatever you want it to be, yep, you get to define it. And a variable is a representation of a memory address. Sweet. Yeah, I think these are all really good. And if I were to kind of summarize it together, obviously if you look up what is a variable online, you'll get a lot of different answers. So take it with a grain of salt. But I think this definition kind of combines a lot of what you all are saying, which is a uniquely named storage location that holds data. And the one thing that I'll call out is that it has to be uniquely named. If you were to try to create a variable with the same name multiple times, it'll throw an error because the compiler will get confused. It's like, you've already used this name before, how can you use it again? So it has to be uniquely named, it references a storage location, and it holds a piece of data. Cool. Any questions? Okay. So we're going to get into some live coding. There's this tool called, it's called Python Visualizer, but they have a C++ option as well. Just zoom in. Yeah, question? I'll put up a link to it in the EdStem, but it's, if you kind of Google Python tutor, I think it should show up. It's more built for Python and Java, so some of the things don't represent as well in C++, but for today, it'll work fine.
Can we also use the scratchpad in EdStem?
Yeah, so the scratchpad is for you to just like play around with whatever code you want, and you can run it and see outputs. Yeah, so entirely for you.
Gotta use this, or can we use the scratchpad?
So all of our assignments will still be in EdStem. I'm just using this visualizer just for this lecture, just so that we can see how the variables are stored.
Okay, so
Yeah.
we should go on that.
Oh, like if you want to follow along and see?
Yeah.
Um,
Oh, no. I thought that's what we was doing.
no, yeah, I'm just going to be coding here. You all don't need to type here, just because we're a little bit short on time, so I'll move a little bit fast. So if we have kind of similar code that we had on the slide, where we have like int age, we'll say age is equal to 18, and then we'll see out my ages, and then variable age. So then we can visualize the execution. Does anyone want to take a guess what the output for this will be? This my age is 18, yeah. Okay, so under the hood, you can kind of think of this blue box as that compiler mapping that we had put up on the slide. And so the compiler has the age. It's not showing us the exact memory address that it's stored at, but the compiler knows what memory address it's associated with. And so now when we run this line of code, right now it's at line 5. If we run it, then it will populate 18 into this box. And so now whenever the code references age, it will come and get this value, which is 18, and it will print out my age is 18. How about if we made the output my age is age? Does anyone want to take a guess of what the output will be here? Yeah.
Would it say my age is age? Like I just said that because it's in quotes, so that's a string.
Yep, exactly. So just as we learned on Friday, anytime you put something in double quotes, it makes it a string literal. So if you put a number in double quotes, it becomes a string. Even if you put what we think is a variable name, if you put that in double quotes, it will become a string as well. So in this case, the age here is just a string literal. It's not actually going to come and look at this. Because it's in double quotes, it's just going to be printed exactly as is. Are there any questions on that? I know that can be a little bit confusing.
So we gotta take off the quotes.
Yes, so if we wanted it to actually be the value 18, then we would have to remove the quotes, and now it goes back to being a variable, right? And you can even see that because age was actually in here too. If you see, it was like my ages, and that one just printed as normal. It didn't say my 18 is 18. It does say like my age is 18, right? Cool. If we were to do something with a string, what we said player. So the visualizer is kind of annoying for strings in that, we'll let it run. It kind of stores the string as like this big like object item. You don't really have to worry about it. I just want to call this out that if you were to use this visualizer and you tried putting in a string, like we would expect it to say jaw, and it just kind of puts like this poop icon. I don't know why. I think the visualizer is just not fully set up for C++. So you'll at least have the name here, but the output isn't going to be what you expect. But for other stuff like doubles and bools, it should work as you expect. So double, we'll say wait, and what's bool is eligible. And so these ones should work. So weight is equal to like 52.4 is eligible equals true. Okay, so it has all 4 of our variables. Again, you can think of the blue box as memory. And then it will go through each of them. So it'll say weight is 52.4, so that gets added to this variable box. Is eligible is equal to true. In coding, true kind of gets simplified to 1, and false gets simplified to 0, which is why you see like the number here instead of true or false. And then age is equal to 18. And so now if we were to use any of these values or print them out, those were the values that we would have. Any questions on any of that? All right. I know this class wasn't as interactive as some of the others, but variables are kind of a complex topic, and I wanted to make sure that we really got to step through all the material. We're starting to have the assignments come up. Again, if you haven't joined EdSTEM yet, please join the EdSTEM. All the homeworks, labs, and announcements will be on there. Number 2, attend office hours sometime in these next 2 weeks. I'll be in the office today from 2 to 5. So swing by. Again, I'll have like Gatorade and other snacks in the office that you're welcome to come and take. And then I'm gonna release homework 1 probably this afternoon. The prerequisite to do homework 1 is that you have to do lab 1 first. So even if you were in the Wednesday or Friday lab, make sure that you come to today's lab so that you can finish the lab. Everyone that's come into lab was able to finish it in the 50 minutes. And so it'll save you a lot of time to just come in, learn how to do it, get the help that you need. So anyways, I'll release homework 1 today, and it'll be due a week from now on August 29th. Yep.
You said we would be finished our homework within
The lab. We'll finish the lab in lab, and then the homework you'll kind of have to do on your own time.
So we have to come out today for Monday or Friday, or already only come if we haven't finished?
No, sorry. If you haven't finished the lab yet, come into lab. If you already came Wednesday or Friday, you're good. Yeah.
Okay.
But if you haven't come to lab, come in today. Today at 5 in this room.
Thank you.
Yep.
I'm not scheduled for Wednesday.
Okay.
So can I come on Wednesday?
So did you come on this past one? Like, have you done lab 1 yet? Okay. If you're free, I'd encourage you to come today to finish lab 1, and then in future weeks you can come in on Wednesday.
Okay, so what time was it today?
It's today at 5.
Today at 5?
Yep.
And I was gonna go to the Google.
Yeah, and that's at 6 in the same building, so you can finish up here and then head over. I think Merrill 111, which is like right adjacent to us here.
Okay.
Yeah.
Thank you.
So yesterday I was in the library. I was trying to set up VS Code for some
Okay.
projects. I was working some side projects.
Okay.
But it wasn't working. It said that it wasn't like included or like found in my library. So I was wondering if you were having office hours today.
Yeah, I'll have office hours, so you can bring it in and we can try to help get you set up
Okay.
on that.
What time are office hours today?
2 to 5 today.
Okay.
Yep.
Thank you.
Yep. Cool. Hey, what's up?
So first, how do you pronounce your name?
Yeah, Professor Ashwin.
Awesome.
Yep.
Okay. Also, I'm John Oliga.
Oh, cool. Welcome. All right, feeling better?
Yeah, I've been taking medicine.
Okay,
so
cool.
I'm
Yeah.
good.
Okay.
But,
See.
So office hours, I'm definitely coming to because I kind of missed the first day and half of today.
Yeah.
Also, you sent me the presentations, right?
Yeah. So they're all. You're in the EdSTEM, right?
Yep.
Okay. So in the main discussion page, like this important links and info, I kind of have everything here, and the big one will be like the lecture slides, readings, and recordings, and so you can always go back and look through some of that material.
All right, thanks.
Yeah.
You said office hours are throughout the week?
Yeah, it'll be Monday, Wednesday, Friday, generally from 2 to 5ish.
Okay. All right, cool. And then I'll come to lab today.
Okay.
All right.
Sounds
see you.
good. See you.
Go back to the, what is it, variable slide?
Yeah, sorry, give me one.